Having a definition for the trigonometric functions for any number, we now would like to look at the domain and range of these functions. And these we can largely discover just based on our understanding of their definitions using the unit circle. Now sine and cosine, those are the simplest. And I'm going to write the definitions in terms of the points on the unit circle for each of these, because we'll be referring to those. So the sine of an angle is the y-coordinate on the point on the unit circle. Okay, cosine is the x-coordinate. Sine or tangent is y over x. Cosecant is 1 over y. Secant is 1 over x. And cotangent is x over y. So let's talk about domain first of all. Remember that, so domain is what we're allowed to plug into the function. It's the possible values of t. We're going to write these domains in set notation, where we write the set of all t, and then we have a vertical line that says such that. And then we put the condition, what has to be true, what values of t actually do work. Well, the y-coordinates, there's no problem finding a y-coordinate on the unit circle. Okay, if I draw it, I'll go ahead and do my quick sketch, and I'm not going to fill out the whole thing, but I'm just going to draw a circle so we can see it. Okay. So the whole set of points here, it doesn't matter what angle we have, we can always find a y-coordinate, right? There's no problem there. That means that our domain here is everything, okay? T can be anything we want. So I can say negative infinity is less than t is less than infinity. That's just set of all anything. We can plug any real number we want into the sine function, and it works out nicely. Now let's talk about the range. The range is the possible output values, and I know that my output values, the sine, is the y-coordinate. So the question is, what are the possible y-coordinates here? Well, I know my very highest point up here is at the point 0, 1, and my very lowest point here is at 0, negative 1. And I can have all the y values in between, okay? And so my range is going to be everything between negative 1 and 1. So again, writing this in set notation, I have the set of all possible y values such that, y is between negative 1 and 1. And we do have equals on each of those because we do actually reach those points. Okay, and then that's our range. All right, looking at cosine, let's talk about our domain of cosine. Now, the cosine of an angle is the x-coordinates of the points. And again, there's no issue ever finding an x-coordinate here. No matter what I plug in, no matter where I am, I will always be able to find the x-coordinate. So there are no restrictions on the domain here. So it's the set of all t between negative infinity and infinity. There are no restrictions. The range is, now this is going to look a little bit confusing because I'm going to say it's a set of possible y, only because here I have y equals. Okay, I know it's kind of confusing because I have this y over here. This is the y on the unit circle. Maybe I'll call that something else. I'll call that y. I'll just have a slightly different notation, just so that we recognize that this y is different. So we're saying the possible things I can get from cosine. Well, the possible things I can get are x-coordinates here, all the way down to this point over here, which is at negative 1, 0, and up to this point here, which is at positive 1, 0. So I can get everything between negative 1 and 1 again. So it's the same as the sine. All right, now it gets a little bit more interesting. Y equals tangent of t. Let's talk about our domain. So we're going to say it's a set of all t such that what condition has to be met here. And, well, we know that our tangent is y over x, which is only a problem if the x-coordinate is 0. We know we can't divide by 0. And that occurs right here. Fill that in a little bit. Right here and right here. Okay. Now those angles, I'm going to write those angles are pi over 2 and 3 pi over 2. Now, if I keep going, this is only in one revolution of the unit circle, but I could keep going. I could say, that's pi over 2, that's 3 pi over 2, and then if I keep going, that angle right there it's a full 2 pi plus another pi over 2, which is 5 pi over 2. Okay, and hopefully you can see is then I add another pi, and I get 7 pi over 2. So it's actually all the odd pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, and so on. Those are not okay angles. Okay, the tangent will not exist there because we'd be trying to divide by 0. So it's all the t. First of all, we're going to go ahead and just say, yeah, t still has to be between negative infinity and infinity. T still has to be a real number. But we also have another condition. So I'm going to put a little comma and write my other condition. T cannot be an odd numbered pi over 2. So t cannot equal, and then we need a way to write odd numbers. And the standard way that we write odd numbers is every odd number is, you can take 2 times an integer, that gives you an even number, and then if you add 1, you get odd numbers. So 2n plus 1 times pi, that's an odd number times pi over 2. Okay, so any real number that is not an odd pi over 2, that's going to be our domain for tangent. All right, the range of tangent is not super easy to do, but we're going to look at our definition. We want to know, what could I possibly get if I take a y value and divide by an x value for our coordinates? And what we have to think about here is, first of all, when we take y and divide by x, we can divide by any number that's as close to 0 as we can imagine without actually hitting 0. And when you divide by something really close to 0, you get a really big number. Okay. But on the flip side of that, we also have really small numbers, y coordinates, divided by numbers close to 1, which are really small numbers. And we've got all the positives of that for our y coordinates up top. And we've got negative with y values on bottom. And of course, positive x values on the right side and negative x values on the bottom. So really, our range for the tangent ends up being everything. Okay, any y from negative infinity to infinity. That's the range of our tangent function. All right, the cosecant function. Cosecant is 1 over the y coordinate. So for our domain, t can be any t as long as y is not 0. Well, looking at our unit circle, y is only 0 in these 2 points here. Okay, 1, 0 and negative 1, 0. And those angles, that's 0 and pi, and if we keep going, it's 2 pi and 3 pi and 4 pi, any integer pi, value of pi. And we can't have those. So for our domain, we're going to say, again, any real number, of course, except we also need t not to be, t cannot equal an integer value of pi. It cannot be, and we'll call that n times pi, where n is an integer. And we should probably say that up here. Let's go ahead and say up here, n is an integer in all of these when we're using n. All right, now for our range, cosecant is 1 over the y coordinate. And all of our y coordinates are between negative 1 and 1. We know that. Right, all of our y coordinates are between negative 1 and 1. So when you take 1 divided by a number between negative 1 and 1, first of all, you can't get a number between negative 1 and 1. Because, for example, to get, say, 1/2, you would have to have 1 divided by 2. But you can't get that. So the range of this is the set of all y, where y is either greater than or equal to 1, or y is less than or equal to negative 1. Okay, When you divide by a number between 0 and 1, you get a number greater than or equal to 1. And if you divide by a number between 0 and -1, you get a number less than or equal to -1. All right, for our secant, we can see for our secant we are dividing by the x-coordinate. So the only restriction is actually going to be the same as the restriction for tangent. Okay, we cannot divide by 0, so we will use the same reasoning. It will have the same domain as the tangent. Okay, set of all t from -infinity to infinity, such that t is not an odd valued pi over 2. The range for secant, we actually use the same reasoning as we did for cosecant. We're dividing by the y-coordinates here, but here we're dividing by x-coordinates. But we know the x-coordinates are also always between -1 and 1. So our range is all possible y values that are greater than or equal to 1 or less than or equal to -1. And finally, for the cotangent function, we have the x-coordinate divided by the y-coordinate. So the domain, we're going to use the same restriction as when dividing by the y-coordinate, which we had up here for cosecant. Dividing by the y-coordinate, you can't divide by 0. So we have this same restriction, all t from -infinity to infinity, as long as t is not an integer valued pi. And our range, we can use the same reasoning as we did for the tangent. Okay, we're dividing the two coordinates, the y by x or x by y. And so when we divide really close to 0, we get really big numbers. And we have really small numbers on top, we get really small numbers. And so we actually end up with all possible values. Y could be anything from -infinity to infinity. Now later, we will see we'll be able to graph these functions and kind of really see these in play and why these are the domain and range. And it will come together a little bit more nicely.